Ashe. My dear friends, I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic applied electronics information session produced by our esteemed elder Baba Jelani Bomani Dembe, the brilliant mind behind Majestic Mind Matters University, and the mandatory Mental Liberation series, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished elder Baba Jelani Bomani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. So pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to the encoder. Encoders are important devices used in many electronic and mechanical systems to convert motion into electrical signals. Applied electronics technicians need to have a good understanding of encoders in order to effectively troubleshoot and repair equipment that uses them. In this essay, we will explore what encoders are, how they work, and the different types of encoders commonly used in various applications. Encoders are devices that are used to convert rotary or linear motion into electrical signals. They are commonly used in industrial systems such as robotics, CNC machines, and conveyor systems to provide feedback on the position and speed of moving parts. Encoders are essential for accurate control of these systems as they provide precise information on the position of a motor or a moving component. There are two main types of encoders, incremental and absolute. Incremental encoders produce a series of square wave pulses as the shaft rotates, indicating the movement of the shaft relative to a reference point. This type of encoder is commonly used in applications where the direction of motion is important, such as motor control systems. Absolute encoders, on the other hand, provide a unique digital code for each position of the shaft, allowing the system to determine the exact position of the shaft at any given time. This type of encoder is used in applications where the position accuracy is critical, such as in precision machinery. Encoders work by detecting changes in the position of a rotating shaft and converting these changes into electrical signals. The most common type of encoder uses a glass or metal disc with slots or marks on it that is attached to the shaft. Light is shown through the slots or marks onto a sensor, which detects the changes in the pattern of light as the disc rotates. The sensor then converts the changes in light intensity into electrical pulses, which are sent to a control system to determine the position and speed of the shaft. Applied electronics technicians need to have a good understanding of how encoders work in order to troubleshoot and repair systems that use them. When diagnosing issues with an encoder, technicians need to check for physical damage to the encoder disc or sensor, misalignment of the encoder components, or issues with the wiring or connections. They also need to ensure that the encoder is properly calibrated and configured for the specific application. In addition to troubleshooting and repairing encoders, applied electronics technicians also need to be familiar with the different types of encoders commonly used in various applications. Rotary encoders are used to measure the rotation of a shaft, while linear encoders are used to measure the linear movement of a component. Magnetic encoders use magnetic fields to detect changes in position, while optical encoders use light to detect changes in position. Each type of encoder has its own advantages and disadvantages, so technicians need to choose the right type of encoder for the specific application. Overall, encoders are essential devices in many electronic and mechanical systems, providing precise feedback on the position and speed of moving parts. Applied electronics technicians need to have a good understanding of how encoders work, the different types of encoders available, and how to troubleshoot and repair encoder systems. By having this knowledge, technicians can effectively maintain and repair equipment that uses encoders, ensuring the smooth operation of industrial systems. Applied electronics technicians need to have a deep understanding of encoders and how they function in order to effectively work with electronic devices that utilize these components. Encoders are widely used in a variety of applications, such as robotics, automation, telecommunications, and consumer electronics, making them an essential part of the technician's skill set. One of the key things that applied electronics technicians need to know about encoders is the different types that are available and their respective functions. There are several types of encoders, including rotary encoders, linear encoders, optical encoders, magnetic encoders, and absolute encoders. Each type has its own unique features and functions, so technicians need to be familiar with the specific characteristics of each type in order to choose the right one for a particular application. For example, rotary encoders are commonly used in applications where the rotation or position of a shaft or knob needs to be measured, such as in rotary motors or robotic arms. Linear encoders, on the other hand, are used to measure linear motion, such as in linear actuators or CNC machines. Optical encoders use light to detect motion, while magnetic encoders use magnetic fields for the same purpose. Absolute encoders provide a unique digital code for each position, allowing for accurate position sensing even after power loss or system restart. Applied electronics technicians also need to understand how encoders are interfaced with other electronic components in a system. Encoders typically output digital signals that need to be processed by a microcontroller, computer, or other device. Technicians need to know how to connect and configure encoders with these devices in order to ensure proper communication and functionality. Furthermore, technicians need to be aware of the potential challenges and troubleshooting methods associated with encoders. Encoders can sometimes experience issues such as noise interference, signal drift, or mechanical wear and tear, which can impact their performance. Technicians need to be able to diagnose these issues and implement solutions to ensure that the encoder functions properly within the system. In addition, technicians should also be knowledgeable about the calibration and alignment procedures for encoders. Calibrating an encoder involves setting the zero position and scaling the output signals to match the physical motion being measured. This process is critical for accurate position sensing and control in a system. Alignment refers to ensuring that the encoder is properly installed and oriented to provide accurate measurements and feedback. Applied electronics technicians should also be familiar with the programming and configuration of encoders. Many encoders come with software tools or programming interfaces that allow technicians to customize the encoder's behavior or output format. Technicians need to be able to navigate these tools, understand the various parameters and settings available, and make adjustments as needed to meet the requirements of the system. Encoders are essential components in electronic devices that enable the conversion of data and signals for a variety of applications. Applied electronics technicians need to have a comprehensive understanding of encoders, including their types, functions, interfacing methods, troubleshooting techniques, calibration procedures, and programming capabilities. By mastering these aspects of encoders, technicians can effectively work with electronic systems that incorporate these devices and ensure their proper operation and performance. Applied electronics technicians play a crucial role in ensuring that electronic systems function properly and efficiently. When it comes to working with encoders, technicians need to have a solid understanding of the various components and processes involved in their operation. Whether it's troubleshooting issues, performing maintenance, or making repairs, there are several key things that technicians need to know about working with encoders. One of the first things that technicians need to check when dealing with encoder issues is the power supply. It is essential to ensure that the encoder is receiving the correct voltage and that there are no issues with the power supply. A malfunctioning power supply can lead to a host of problems, including erratic behavior, incorrect readings, or complete failure. By checking the power supply, technicians can pinpoint any potential issues and address them before they cause further damage to the encoder or the overall electronic system. In addition to checking the power supply, technicians should also inspect the connections between the encoder and the rest of the electronic system. Loose or improperly connected cables can lead to signal loss, intermittent connectivity issues, or even damage to the encoder itself. By carefully inspecting all connections and ensuring they are secure, technicians can prevent potential problems and ensure that the encoder operates smoothly. Another important step in maintaining encoders is to regularly clean them. Dust, dirt, or debris can accumulate on the encoder over time, leading to malfunctions or inaccurate readings. Technicians should use a soft brush or compressed air to clean the encoder thoroughly and remove any buildup that may be interfering with its operation. Furthermore, technicians need to check for physical damage on the encoder. Cracks, missing parts, or signs of wear and tear can indicate that the encoder is damaged and needs to be replaced. By inspecting the encoder for any physical damage and replacing damaged components, technicians can prevent further issues and ensure that the encoder functions properly. Testing the encoder outputs is also an essential step in troubleshooting encoder issues. Using a multimeter or oscilloscope, technicians can test the outputs of the encoder and ensure that they are functioning correctly. This step helps identify any problems with the encoder signals and allows technicians to make necessary adjustments or repairs. Additionally, technicians need to be aware of electromagnetic interference that may affect the encoder's performance. Nearby electronics or machinery can emit electromagnetic interference that disrupts the encoder's signals. By ensuring that the encoder is shielded from such interference, technicians can prevent malfunctions and ensure the encoder operates smoothly. If the encoder is controlled by firmware or software, technicians should check for updates or glitches that may be causing malfunctions. Updating the firmware or software can help resolve issues and improve the encoder's performance. It is also important for technicians to consult the manufacturer's documentation for troubleshooting tips and repair guidelines. In some cases, recalibrating the encoder may be necessary to ensure accurate readings and smooth operation. Technicians should follow the manufacturer's instructions carefully when recalibrating the encoder to avoid any errors or malfunctions. If none of the above steps resolve the issue, technicians may need to consider replacing the encoder with a new one. While this may be a last resort, replacing the encoder is sometimes necessary to ensure the overall functionality of the electronic system. In conclusion, applied electronics technicians need to be well-versed in the various aspects of working with encoders. By following these key steps, checking the power supply, inspecting connections, cleaning the encoder, checking for physical damage, testing outputs, addressing electromagnetic interference, updating firmware/software, consulting the manufacturer's documentation, recalibrating as needed, and considering replacement, technicians can effectively troubleshoot issues, perform maintenance, and make repairs to ensure that encoders function properly and efficiently. Ultimately, having a comprehensive understanding of these aspects is crucial for maintaining electronic systems and ensuring their optimal performance. Thanks for your participation in this special Majestic Mind Matters University Basic Applied Electronics Information session. I am your royal narrator, Queen Magical Melanin. Here is a special message from our esteemed Elder Baba Jelani Bamani Dembe, the brilliant mind behind Majestic Mind Matters University. To all applied electronic technicians, he wants you to know this. Your participation with Majestic Mind Matters University has been invaluable. Your expertise and commitment to excellence has elevated our research and knowledge in the field of applied electronics. Thank you for choosing Majestic Mind Matters University as a trusted source for your valuable applied electronics information to aid to your success with this basic applied electronics information session titled Introduction to the Encoder. Stay woke. Ashe.